Ever stop to think about that little bit of, well, magic that happens when you flip a switch? A fan starts to spin, an electric car just silently glides forward. It all comes down to this one fundamental principle of physics. It's like a hidden force that connects the electricity in your walls to the actual motion that powers, well, pretty much everything in our world. So, let's pull back the curtain on that secret.
So yeah, the core question is actually pretty simple. How do you turn a flow of electrons, something you can't even see, into the real physical movement of a machine? I mean, it seems like two totally different worlds, right? But as we're about to see, there's a very powerful bridge that connects them. And that bridge, it's got a name: electromechanical energy conversion. In a nutshell, it's the process where we use magnetic fields to translate electrical energy into mechanical energy. And, as we'll find out, it works the other way around too. This one single concept is the foundation for pretty much every electrical machine you can think of.
All right, so here's how we're going to tackle this. First, we're going to look at the big picture of this energy transformation. Then, we'll zoom right in on the fundamental force that's doing all the work. After that, we'll meet the three key players involved, walk through exactly how the conversion process happens, and then finally, we'll see how this all comes together to power our modern lives. Okay, so let's start with just how huge this idea really is. And I'm not talking about some obscure little piece of science here. No way. This is the core principle behind every single electric motor that spins and every generator that creates the power for our homes. It really is a great transformation of energy from one form into a completely different one. So, how does it actually work? Well, at its heart, this massive, world-changing concept really just boils down to one single, clean, and kind of elegant interaction. Just one physical law that makes everything else possible.
And this is it. This is the secret sauce, right here. The whole idea is that when you get electricity flowing through a wire, and that wire is sitting inside a magnetic field, the wire gets pushed. That push, that little mechanical force, that's the birth of motion from electricity. Everything, and I mean everything, builds on this one simple fact.
Now, what's really cool is that this principle is a two-way street. You put electrical energy in, you get physical motion out. Boom, that's a motor. But you can also do the exact reverse. You use physical force to create motion inside a magnetic field, and you get electrical energy out. And that's a generator. They are literally two sides of the exact same coin.
So, to make this conversion actually happen, you need three essential components. Think of them as three key players on a team. And you need all three, otherwise the game just doesn't start. Nothing happens. First up, player number one, the electrical domain. This is our input, right? It's our power source. You've got the voltage giving the push and the current actually flowing through a wire. This is the energy we start with, the one we want to transform. Then you've got player number two, the mechanical domain. This is our goal. This is the output we're trying to get. It's the actual force, the torque, the physical motion that's going to do the work for us, whether that's spinning a fan blade or turning the wheels of a car. So you have electricity on one side and motion on the other. What connects them? What's the bridge? The absolutely essential link between these two worlds is the magnetic field. It's the matchmaker, the coupling medium, that allows these two very different types of energy to talk to each other and, convert.
Okay, so we've met the players on the field. Now let's look at the actual play. How do they work to get this job done, step by step?
It's really just a beautiful, logical sequence, like a perfect four-step dance. Step one, you send electricity into a wire. Step two, that current automatically creates its own little magnetic field around the wire. Now, step three is where the action is. You put this wire inside another, bigger magnetic field, and the two fields interact. They push and pull on each other. And finally, step four, that interaction creates a force, and that force produces motion, a perfect little chain reaction.
And, whenever there's physics, there's got to be an elegant equation, right? This simple formula, which is part of the Lorentz force law, tells us exactly how much force we're going to get. You can think of it as the mathematical recipe for making motion out of electricity.
And let's just break that down real quick. The force you get, that's F, is directly tied to the strength of your magnetic field, B, the amount of current you're pushing through the wire, I, and the length of that wire that's actually sitting in the field, L. So you want more force, you want more oomph, just turn up the dial on any of those three things: a stronger magnet, more current, or a longer wire. It's as simple as that.
But of course, just like with anything in the real world, this whole process isn't 100% efficient. You can't get something for nothing, right? The law of conservation of energy always applies. So the electrical energy you put in has to equal the mechanical energy you get out, plus any energy that gets lost along the way. And that's usually in the form of waste heat or maybe a little bit of friction.
Okay, so enough of the textbook formulas. Let's zoom back out for a minute and really talk about the absolutely massive impact this one single principle has on every single one of our lives.
I mean, just look at this list of applications. We're talking electric motors in everything from your kitchen blender to massive industrial factories. Generators in every power plant. The tiny little switches in relays and solenoids. The entire powertrain of an electric vehicle. And even huge renewable energy systems like wind turbines, which really are just giant generators. Every single one of these runs on this exact same principle.
Just let that sink in for a second. This one idea that a current inside a magnetic field creates a force is the bedrock. It's the foundation that our entire electrified, mechanized civilization is built on. It is, without a doubt, one of the most important discoveries in all of human history.
And so that leaves us with a pretty fascinating question to think about, doesn't it? Electromechanical conversion absolutely defined the technological explosion of the last century. So as we're looking ahead, what's next? What's the new principle of energy conversion, maybe one we haven't even discovered yet, that's going to shape the world of the future?